All right, I wanted to create a quick video here to sort of support you in your quiz review about imaginary numbers. So I have this PDF that I've provided all my students, and remember that I equals the square root of -1. So wherever you see an I, you need to think about that being a radical. It's actually the square root of -1. And then anytime you see an I squared, you replace it with -1. I've got a typo here. I squared is -1. So anytime you see an I squared, you need to replace it with -1. So on this problem number 3 here, you see we've got an I squared that's going to pop out here. When we take I times I, we get I squared, just like when you take x times x, you get x squared. So this is -6 I squared, which is -6 times -1, which is +6. So the answer here is +6. Number 4, same thing, right? We got I times I. So this would be 20 I squared, and that would equal -20 because I squared is -1, right? All right, moving on. Number 5, we have a -I times a +8I. So what's a negative times a positive? Sign first. Negative. And then what's 1 times 8? 8. And then we have I squared. Now anytime you have an I squared in here, you replace it with -1. So this becomes -8 times -1, which is +8 in the end. +8 in the end. All right, number 6 over here. We're going to square 3i. So that means 3i times 3i, which is 9i squared, which would be -9. So anytime you see an I squared, replace it with -1 and then work it out from there. All right, simplify the complex number. So here we have an 81 under a radical. That's of course a perfect square, and we have a negative sign. So this becomes the square root of -1 times the square root of 81, and this sort of process can be done mentally eventually. So this would be I times 9, and we just write 9i, not negative, right? The negative sign under the radical is taken care of with the I. So we don't write a -9i. It's actually positive here. This next one, the square root of 156. Now 156 is not a perfect square. So let's divide it up and just see how it divides. So this would be 3 times 52. This would be 26 times 2. This would be 13 times 2. So it sure looks like the 156 is divisible by 4, and then left behind would be 39. 4 times 39, because 3 times 13 is 39. So this would be 2i radical 39. Again, let me check this. So 39 times 4 is 6. Carry the 3, 156. So I did do that arithmetic correctly in my head here. So that 39 does not have a perfect square in it. Okay, so there's nothing else that can come out. The minus sign here is reflected in having this I on the outside. Okay, over here. Now because it has a minus sign on the inside of the radical, we know our answer is going to have an I in it. And 28 is 4 times 7. So that's 2 radical 7. 2 radical 7. Now there's a pair of x's under this radical, so out comes one of them. There's 3 pairs of y's and an oddball, an extra, a remainder. So we have y to the third on the outside. 7 divided by 2 is 3, remainder 1 under the radical. So the answer would be 2x y to the third I radical 7y. Okay, we've got one more over here. This is clearly 10i, right? Because the square root of -100 is 10i. Now, I think we may have some extra things that can make their way out here. We have an x squared that can make its way out, leaving an x on the inside. We have 5 y's that can make their way out, and 1 z. Again, because 10 divided by 2, this is a square root, is 5. 2 divided by 2 is 1 factor of z, and then we have the I there with the lone x remaining under the radical. Adding complex numbers. These are called complex numbers because they're of the form a plus bi. They've got a real part and an imaginary part. Think of it as x's. They're like terms. So we just add 9 plus 1 and we get 10. And then we add our 4i and our negative 1i is 3i. And you could do all that in your head. It's just combining like terms. Just combining like terms is all that is. Over here, subtraction. We want to distribute this minus sign, so we get negative 7 minus 5i plus 3 minus 2i, and then combine the like terms. So we get negative 4 minus 7i. Negative 4 minus 7i. Over here, oh, this is not an addition or subtraction. This is multiplication. So I usually use the FOIL technique on something like this. First, outside, inside, last. So we get 48 minus 6i plus 40i. Of course, those are like terms and we'll combine, right? And then minus 5i squared. Combine these middle terms, and I get positive 34i. And then, oh, I spy an I squared right here. There's an I squared there. So this becomes positive 5 when you replace the I squared with the negative 1. And positive 5 and positive 48 is 53. So put a box around that. That's in the official complex number form. Okay, moving on down here. Oh, now we're doing division. Now remember how you did this with radicals. You multiplied by the conjugate. Well, remember I is a radical. It's the square root of negative 1. So I'm going to multiply by the conjugate of the denominator, 1 plus 2i. And just see where this takes me. 1 plus 2i. Okay, so on the bottom, it's a difference of squares. So you end up getting 1 minus 4i squared, which is 1 plus 4, which is 5. Right? This is 1 plus 4. When you change the I squared into negative 1. Now on the top, we'll have to FOIL that. So here we go, 7. And then on the outside, we got 14. On the inside, we got 4. That's 18i. And then the last is going to have an I squared. So it's going to be the whole that whole negative 1 thing. So plus 8i squared. So that's really negative 8. So the answer is negative 1 plus 18i. Remember, this right here is really negative 8. Negative 8 and positive 7 is how I got that negative 1. Now that's not officially in the right form, so let's go ahead and split it up and write it in our a plus bi form. So it would be negative 1/5 plus 18/5 I. That's really the best way to write it right there, complex number form. All right, here we have a square of what's almost like a binomial, right? Where I is a variable, it's really a constant, it's a square root of negative 1, but we still want to multiply this out. So if you need to use the FOIL technique, you could write it out like this, or maybe you have the pattern memorized, which hopefully you do. Okay, so it's going to be 16 plus 64, because 32 plus 32 is 64i. And it's a negative, or I'm sorry, it's a positive 64 because a negative times a negative makes a positive on both the outside and the inside. And then we have plus 64i squared. Now that becomes negative, right? That becomes negative 64. So we get negative 48 plus 64i. That's what I get right there when I square that complex number. And there you have it. There's the quiz review. The one item that I did not do that I think I want to add one of them on here if I could. 1 plus 3i divided by 5i. How would we do that? Because that's the division problem, but this time I don't use a conjugate on the bottom. I just multiply by I over I. And that means I need to distribute it on the top. So we get 1I plus 3I squared all over 5I squared. Okay. Anytime you see an I squared, you replace it with -1. So it becomes I minus 3 all over -5. And then written in the correct form, it would be 3/5 minus 1/5 I. Let me show you where on earth I did that, okay? Here's where the 3/5 came from. -3 divided by -5. And then here's where the -1/5 I came from. You see it? All right, hopefully you're ready for your quiz, so we'll see you in class. Ready to go? All right, good luck.